Hello, everyone, and welcome to this webinar, Transforming Your Security Strategy, Unleashing the Power of Cisco Secure Firewall and Cisco Secure Workload to Simplify Macro and Micro Segmentation. My name is Jorge Quintero, and I am a technical marketing engineer with Cisco Security Business Group. So why are we here, right? And to answer that question, we need perhaps to step a little bit back, right, for around 2 decades, right? And what you see here is this common or standard network security architecture, right, where you have this network security controls, right, in the form of a firewall or a next generation firewall protecting access to your applications workloads in the data center, right? So this firewall is typically sitting at the edge of your data center, right at the perimeter, to control whatever is coming in and is authorized, as well as controlling whatever is going out from your data center, right? And so far, so good. We have been protecting our application workloads this way, where we perform this policy authoring, right, based on the different permissions that our users or external entities have to our assets or application workloads. However, the challenge with this common architecture is whenever they get compromised, right? As we know by now, right, no defense is 100% proof, right? And in this case, if the attacker just have one chance, right, that they can effectively breach those defenses, right, they might get that initial foothold. So we need to get it right every single time, right, 100% of the times to avoid that compromise from these attackers, because they will keep going, they will keep trying to compromise our defenses. Now, this is not the only part of the story, right? As I said before, once they manage to get that initial access, right, that initial footprint on your network, they will try to move laterally, right? They will start scanning, looking for additional workloads they can compromise, right? Eventually getting to your crown jewels, and they will try to perform privilege escalation and eventually do exfiltration of that data. By that time, right, at that moment, you are already part of a ransomware attack where they might just send an email to you or some sort of notification that they have your data, right? And if you don't pay some sort of cryptocurrency, they might leak that information, and that may also have, of course, some brand and reputational impact, right? And this is the reason why we're here today, right? We are here today to understand how you can use Secure Firewall and Cisco Secure Workload to prevent that lateral movement, right, from attackers, right, to contain them. So even in the worst case that you get compromised, right, from a ransomware attack, you can contain those attackers and eventually evict them out of your network. Now, why this is so difficult, right? We understand the problem, right? However, resolving it has been a little bit elusive. And if we look at the application workload evolution, we can understand why, right? If we look, again, 20 years back from now, most of our application workloads were based on a bare metal form factor, right? So it was ideal to protect those workloads using these edge firewalls, right, or these perimeter firewalls. However, we saw how those form factors evolve with new technology, right? Back then with the virtual machines, right, allowing us to abstract that hardware, right, resources and virtualize our workloads. Then we saw the public cloud, which got even one step further, right? Now it is abstracting as well that infrastructure part, where this cloud service provider just offer us, using the resources for consumption in a subscription matter, right? So it's very convenient. Then we saw the containers and Kubernetes, right? The Kubernetes orchestration or container orchestration wave, and by now we can tell that this cloud native approach, right, has been standardized in a lot of companies, and more companies are already going into that direction of application workloads architecture. And even, right, we also have other ways of provisioning these resources, right, in the form of serverless, right, where cloud service providers or the provider of this serverless service, they abstract even the operating system itself, right? Offering you some sort of subscription to the runtime of your choice, right? The language runtime of your choice that can be, for example, Python or JavaScript or some Node.js, just to say some examples, right? So the message is clear, right? These application workloads are evolving with new technology, and our current network security approaches, they need to evolve with them, right? Because they cannot keep the same pace, hence making it more difficult to protect them, right? But a part of that, right? If we go to each organization and we start asking, different personas and different operators within the different departments of each organization, we see that they have different definitions for what an application workload is, right? Starting from the network engineers, right, where they will typically define an application workload based on networking constructs, right? For example, the VLAN where it's located, the subnet where it belongs, or the contract or access control list that it has, right? Depending if you have SDN, right, the software-defined networking, or traditional networking. You also have the firewall engineer, which he speaks a similar language as the network engineer, right? They usually work within the networking constructs, right? With some subtle differences, right? For the firewall engineer, it comes more to the zones, which still is a boundary to define different subnets, right? As well as the access control list that they use to permit or deny traffic flows within the network. Then you have the cloud engineers, and here's where that definition starts to change a little bit, right? They do use similar constructs, right, as the network and firewall engineer when it comes to networks, for example, subnets, right? But in the context of the cloud, this operates in a different fashion, right? We have the VPCs, right, or VNets for some cloud service providers. They're defined as these virtual private clouds or virtual networks, right, where you provision your application workloads. And you also have some built-in mechanism on the cloud to restrict access, right? And keep in mind that in the cloud, all of this networking is abstracted, right? It's just defined as an intention, right? So here we see how those constructs are already changing, right, from an implementation and operational point of view. Then we have the application owners, and of course, application owners will not speak in networking terms, right, or networking constructs. They speak mostly on their own application development, right? For example, the service the application is offering, the application itself, right, the language they're using, or the workload itself, right, if they also are responsible for the form factors. And lastly, the cloud native engineer, and depending on the organizations, they might be called the platform engineers, right? And this persona is dealing with the cloud native constructs, right, in the form of Kubernetes objects, right? For example, namespace, services, CNI, which are completely different constructs than the others that we have been used to, especially networking and firewall engineers, because this is a different world, right, of how you provision and deploy application workloads. And this, of course, creates some contention, right, between all of these different personas, because each one already is already implementing some sort of policy controls, right? Starting for the network security, right, where the network engineers and firewall engineers will intersect, right? They are already defining the segmentation policy or the security policy to access the resources, right? And they might be executing it as well using this typical constructs, right, in the form of firewalls, load balancers in some cases as well, right? And then we have the workload security, which depending on the organization and organizational maturity, this responsibility may have shifted already to the workload admins, right, or VM admins, or it may be a shared responsibility between the network security and the workload administrators, right, where the network security folks will define the policy and the server or VM admins will be in charge of executing that policy, right? And how do they execute that policy? Well, they are already leveraging some enforcement points, right, or some enforcement controls, right, that are living within those workloads in the form of host native firewalls, right, such as Windows firewall or Linux firewalls, all right. Then we have the cloud security, which this responsibility again depends on the maturity of the organization. And the reality is that this persona, the cloud architect or cloud engineer, is already leveraging some built-in security controls, right, in the cloud in the form of security groups to control the access to the application workloads, right? And lastly, we have the cloud native security that is usually in charge of the DevSecOps personas or the platform engineers. And this responsibility, right now is currently isolated, is currently governed by this type of personas, but the reality is that eventually the at least the policy definition might shift to the network security, right, or the security administrators, because they are the ones in charge of defining that policy, right? And eventually the execution might be kept within this type of persona, right? But the reality is that right now they're operating in silos and they're already using some of the constructs available for them in the form of network network policies from the CNIs, right, from this container networking interface in Kubernetes cluster, or other ways to implement that segmentation control, right? And what you can see here clearly is that we have a triad, right? We have different people, processes, and technologies, right, creating this computational and organizational challenges where you have all of these different teams operating in silos, and that they create these inconsistent islands of policy controls where attackers can thrive because of this inconsistency, right? Because of these missing gaps. And here is where secure workload comes into place, right? Basically, you have this centralized policy control engine, right, to enforce in a distributed fashion those policies that you define. Now, of course, there is a process for this, right? Because you don't want to enforce just policies just because, right? Especially when this is being enforced in multiple types of enforcement points. So the very first step is to get visibility, right, from all of those different enforcement points that can be, for example, the workloads themselves or the network, right? And that visibility, we pair it with some context, right, to perform the workload or asset discovery. That discovery is done using labels within the system, right, within secure workload, or integration with the external system of records such as ServiceNow, Infoblox, DNS servers, VMware, cloud service provider, among others, right? Once you have that discovery is where you have this policy discovery engine that leverages AI machine learning to discover the policies from those application workloads, right, from those assets. So it suggests those policies to you so you can have that that segmentation policy for those specific applications. But before enforcing it onto the network, it also offers this policy analysis toolkit, so you can stage those policies, right? And you can validate those policies with real networking traffic from your organization, right? To make sure that intent is correct, right? That it will not cause any harm on the network. And finally is where you will proceed to enforce those distributed policies onto these different enforcement points, right? That can be host, right, directly on the workload using the host native firewall, such as Windows Firewall or Linux IP tables, or as well on Kubernetes clusters, right, using the Linux firewall, right? On the cloud, that can be, in this case, using the built-in security controls of the cloud, such as the security groups or network security groups, or into the network itself, leveraging the native integration with secure firewall or our integration with the DPUs, these data processing units that can live within workloads, right, within the servers themselves. And these are secure workload use cases, right? We have microsegmentation, we have vulnerability detection and protection, and behavioral detection and protection. For today, the focus is on microsegmentation, right? Where you can leverage both secure workload and secure firewall, right? Depending on your segmentation needs. And here is where when we start talking about this end-to-end segmentation, right? And Cisco is one of the few, if not the only one, that can offer to you all of this um, different capabilities, right, to meet you at the level of segmentation that you need, right? Even from IoT, OT environments up to the application based segmentation, right? We're focusing now more on the data center and campus side, right? We can go all the way from the perimeter down to the application level itself, right? And here we have two interesting use cases. The first one is the intelligent zone firewalling, where you have secure workload and secure firewall working in tandem together, right? To have this macro and in some extent some micro segmentation, right, within the environment. And then, of course, up to the application level is where you will have secure workload, right, leveraging this microperimeter right there at the application or workload level, right? And here is for this intelligent zone firewalling, where secure workload will ingest this visibility from secure firewall in the form of NESL or these NetFlow records, right? Where the secure firewall will stream all of this different telemetry information, right, from the network to secure workload, where it will discover policies, right, intelligent policies for your environment, and then it will push that policy to the firewalls, right, in those different environments that can be on premises protecting bare metals or VMs, or as well on the public cloud protecting those instances directly there, right? And this is how it looks, right? For this on-prem and cloud firewall protection, leveraging the secure workload and secure firewall integration, where secure workload supports both modes of operation from secure firewall, that is the transparent mode or layer 2 firewall mode, right? And the L3 or routed mode, right? Depending on how you use it in your on-premise data center. And it also allows for policy dual management, where you have this automated or orchestrated secure workload owned policies. And on top of that, you can have policies that are owned by the FMC or firewall admin, right? Those that are manually controlled by this type of persona. And of course, it's convenient for both the network and firewall engineers so they can govern and control those policies, right? It can be either on FMC or secure workload. Also, we have this functionality of intelligence on firewalling with software-defined networking, and in this case with ACI. The difference here is the insertion mode, right? In this case, the insertion mode on ACI is done through the service graph policy-based redirection, where it can again be inserted in both modes, transparent or routed mode. And the interesting case of this approach, and especially using ACI, is that you can have multi-policy management, right? Some policies orchestrated by workload, let's say those micro-segmentation policies, right? These fine-grained policies, then more macro owned on the FMC level. And if required as well, you can have some policies at the ACI level, right? Owned by the network or ACI engineer, right? In the form of EPG contracts or ESG contracts. Now talking about microsegmentation, right, where we want to implement that microperimeter directly on the workloads. And in this case, we install agents, right, that they're provisioned from secure workload into the workload operating system, right? That can be, for example, Windows OSs, where we'll control the Windows firewall, or Linux OSs, where we will control the Linux IP tables, right? We also support Kubernetes orchestrators such as OpenShift, right? And vanilla Kubernetes, for example, if you're doing this on premises, or in the cloud, that in this case will be a managed service, Kubernetes service, right? In this case, for example, AWS EKS or Azure AKS or GCP with the GKE engine, right? This Google Kubernetes engine. And something important to mention here, right, is that by using the agent to have that microperimeter at the workload level itself, a part of offering in-depth workload protection, it also offers full runtime visibility of that workload. And by runtime, we mean you can get full understanding of what software or software packages are installed in that workload and the vulnerabilities associated with those packages installed there. You also get, for example, a process snapshot, right? If a process is malicious or is banning process, how much resources a process is using, as well as the vulnerabilities related to that process, right? So you get in-depth information of the workload itself, and it also allows you to delegate the policy controls to the application owners, right? So the application owners can own that policy there, right? With RBAC, of course, where they can define the policies they need for the application workloads. But of course, on top of that, and we will check that later on during the presentation, you can still define some policy guardrails. So even those application owners, right, while we are providing them with um, some permissions, right, to own those policies, they will operate within established guardrails of the organization security policy, right? And also, additionally to mention here, right, is that that same agent that you can use to install on these operating systems is not only limited to on-premises. Actually, this can be installed on any cloud, right? As long as we support the operating system, it doesn't matter where it lives, right? It can be on-premises, it can be in any cloud, such as AWS, or Azure, or GCP, as long as we support the OS, right? And you can perform the same action. You can delegate those policy controls to those specific application owners. For Kubernetes microsegmentation, a part of offering that in-depth workload visibility and protection, we go up to the container level, right? We can, for example, we will see the vulnerabilities on the containers images because we can scan those Kubernetes images of the Kubernetes cluster, as well as understand the Kubernetes cluster constructs. So you can perform this segmentation within namespace, right, or referred to as intra-namespace or inter-namespace, cluster level, or even service level is required, right? So it can go as granular as you require, allowing the effective delegation of these policy controls to the cloud native engineers. Now we will talk about the policy lifecycle. And the important part here, right, is that it's not only about defining policies, right? We need to scale that policy lifecycle management when we operate with multiple workloads, right? Usually in the order of thousands, right? And here's where this policy lifecycle with secure workload is fully automated and can scale up to your requirements, right? It starts with the discovery of those policies, right? And those policies can be defined manually as well if required, or even automated using DevOps approaches. After discovering that policy, you want to validate, right? You want to make sure that that policy will perform as intended, right? That no deviations will happen for it or no harm to the environment. And after that policy is validated, then you proceed to enforce those policies in this distributed fashion across all workloads in all of those different environments, right? Can be on premises or multi-cloud. And then, of course, you want to validate and check for compliance, right? That your network, right, and those traffic flows are in compliance with the policies deployed throughout all of the organization. And this policy engine, as I mentioned at the very beginning, right, it's supercharged with AI and machine learning. So we discover those policies intelligently using those technologies, right? You can also automate the policy definition and discovery, and you can analyze for with policy analysis for impact, right? If some policy might not be behaving as it should before you enforce it into the network. And lastly, you can also quickly roll back, right, policies to a previous version if required, right? So all of this without impacting the application workloads. And this is how it starts, right? This policy engine where we do this workload discovery using labels, right? You may also heard about tags or annotations, but this is basically just some context, right? That we identify or give identity to the workloads. And that can be manually using secure workloads labels that we can scale up to 32, or with external integrations with other systems, right? For example, CMDBs or IPAMs or virtual machine managers and so far and so forth, right? So we ingest that context to discover the workloads in the environment, right? And once those workloads are discovered is where we proceed with the policy discovery, right? And this policy discovery, it can be defined in multiple ways, right? The first one is a manual base, is a manual way, right? With these guardrail policies where you define those policies manually, but with human intent. For example, production cannot talk to non-production, right? That might be a security breach that shouldn't be happening. Usually, these development workloads, they don't have very good hygiene, right? Then you have these application granular policies where you can still do it manually with the ring fencing concept, right? Of whatever is coming to your application and you want to restrict, right, that traffic flow, whatever is going out of your application and whatever should be allowed within the application itself, or you can discover it automatically using our application dependency mapping, right? Where you will take advantage of our AI and machine learning algorithms to discover those policies for you. And the last one is with policy as code. This is basically programming the policy, right? Using different approaches. For example, the Open API, um, using common languages, for example, Terraform or Ansible, right, to provision those policies. That can be as well part of a CI/CD pipelines, right? If you have, those DevOps practice or very savvy application owners that are already leveraging this and want to program their policies as part of a stage in their CI/CD pipeline. Then this policy discovery, right? Talking a little bit more about it is when you um, need something, right? Because uh, defining policies for application workloads is not a trivial action, right? Usually, us as network administrators or network engineers or network security engineers, we don't know how those applications behave, right? Because we haven't developed them. So this is a key challenge that you need something to discover those policies for you, and this is where the application dependency mapping comes in, right? So it leverages this machine learning and AI algorithms to discover the policies that that application requires as a blueprint, right? So then you can start validating that policies and fine tune it if required, right? So you can make sure that there are no policy deviations, and once that policy is pushed into the environment, it will behave as intended. And lastly, right, we have the policy enforcement, right, as the last stage of this policy engine, where these policies are enforced dynamically, right, following this human intent-based policy, where you have this, let's say, these mandates, right, or organizational requirements for security policy, often defined by the InfoSec owners or network security administrators, right, at the very top level of your hierarchy, right? And then at the very bottom, you will have the application specific policies for those applications. And the goal of this is to follow that human intent, right? Where we can delegate policy controls to the application owners so they can have some freedom, right? Defining how their applications should behave, but that they are operating within the guardrails of the organization, right? And these guardrails that are defined by the organizational security requirement. And the end result of this is to have these consistent allow list policies across all the environment, right? Now we will do a quick tour, right, of secure workload and uh, and FMC. So where we will see how this this integration, right, and when you have secure firewall and secure workload in tandem, how it can assist you, right? So this, what you see here is my FMC. right? Where we have multiple firewalls, right? We can see that we have some cloud firewalls, we have some firewalls on premises, right? Divided in edge and DC. I will come later on to the firewall management, but first I want to show you secure workload, right? And secure workload, this UI view that you see here is what we call the scopes and inventory view, right? That is just right here in organize and scopes and inventory. And this view over here is basically to define your organization's, right, uh, hierarchical structure, right? Well, you will have your organization at the top level, right? In this case, I have Acme Corp, right, where we define using queries, right? Human queries, we define the inventory of our organization, right? And we can use, for example, integration with other systems, right? When we gather that context to discover those assets, right? And you can see how we define different environments within the organization, right? For example, cloud, in this case, we have AWS, Azure, GCP, right? We have manufacturing, we have data center, right? Where we have multiple applications within our data center and the different environments are living within it, right? For example, production, development, and common services, right? Or shared services, right? So the entire goal of this is to discover the assets, right, and create an inventory, right, depending on where you are within your organizational hierarchical structure, right? And this discovery, right, using these labels that you see here, is giving me the segue, right, to navigate to label management. And this is where we have the full view of all the labels that we are ingesting, or we have defined manually in secure workload to discover those assets, right, and those application workloads, right? So you can see here in label source, if I click on here, the different sources where all of these labels or context is coming from. For example, if I select user defined, you will see here the ones that I have defined manually for my application workloads and my networks, right, and my environments. For example, here in the application, right, if I expand on it, you will see the different IPs and the value that is associated to this, right? That can be an application, right? In this case, we see the jump host, the on-prem e-store, terminal services, finance app agent, right? Or for example, compliance, right? If you have workloads that need to be are, for example, regulated with PCI, right, or DORA, or NIS2, or HIPAA, among other um, um, compliance frameworks, right? Environment as well, right? You can see here the different environments that we have per asset. So here, basically, you give context, right, to the application workload. So these application workloads can be discovered on context, right, on this identity. So right now we're looking at the ones that I have defined manually, but you can see, for example, here that I can integrate with ICE, right, and get that context from ICE, right? For example, the security group tag, right, that I have over here, right? If it is from coming from sales users or IT admins or contractors or developers, right, or even the ICE username, right? Which user is logging there, right? So we get this directly by integrated with ICE in the form of PX Grid. We also have the different cloud service providers, right? GCP, Azure, AWS. I will just click on AWS so we can see, right? We can see here these tags that have been defined on AWS and how I'm ingesting that to perform that discovery, right, of those workloads. We also have, for example, Infoblox, right, or vCenter, or ServiceNow, right? That we can integrate and get that context from those external systems, right? So I will just close here, right? And now coming back to our scopes and inventory, right? Now here I will navigate to the finance app, right? And this finance app is behind a firewall. And we will see here the policies, right, that we have automatically discovered for this finance application, right? And you can see here how all of these policies were discovered automatically for this application by secure workload, right? We can see how sales users are accessing the application, right? And we can see how we are discovering those sales users, right? In this case, using ICE, right? And the ICE stack, right? The security group, or the identity group, right? That we see where these users belong to, and we see how all of this is being dynamically discovered. So you don't need to provision policies for this manually. As long as someone that connects to the network, right, and belongs to any of these two groups, right, either the security group tag or the group sales, it will be automatically put within this policy. And we see how it's accessing the front end, right, of our organization, of our application, right? We see here the query for front end, and we see the IP address related to this, right? So we see all of this full in-depth visibility where we'll discover those policies, right, automatically for your applications, and then you can validate, right, if those policies are behaving as they should with policy analysis, right? So this traffic that you see here is real traffic that we have seen through the network, right, and is hitting a policy, right, that it's being allowed or denied if it is denied, right, if it is not hitting any policy, right? And here we can see, for example, right, the policy that is hidden in this case is, if I just quickly click here on quick policy analysis, well, we'll just find it out very quick, right? And you can see here, right, that this is the Redis cache to the DB nodes policy that is allowing this traffic. Right. So now before navigating to secure firewall, right, in this case FMC, right, I will actually navigate there first. And before going to the access control policies, the firewall in scope are these two HA firewalls, right? The FTD DC core, where we have two firewalls in HA mode, right? And they are in routed mode, as you can see. So now we'll navigate to access control. And here in access control, the policy in scope is the DC core policy, this policy that you see here, right? So we already have integrated our integration through a connector, and I will navigate there just in a moment, right? And we can see how secure workload is already automating what we refer to as golden rules, right? These rules that are meant to allow agent traffic no matter what, right? We don't want to block that type of traffic because then we might block those specific enforcement points, right? So that's why they are on the very top, right, to allow that traffic to secure workload cluster. And just below it, right, we see manual rules defined within FMC, right? The first one, of course, into the mandatory section, right? And then on the default, right, where we have this DHCP policy. Now we'll navigate back to Cisco Secure Workload, and we will proceed to enforce this specific application workload policies, right? So I click on Enforce Policies, and I will follow this wizard where we can see the multiple versions of this policy, right? So we can quickly roll back to any other policy version, right? For example, if there's a human error or human mistake, we can quickly revert, right, those changes. We can see as well the policies that we will push, right, to this enforcement point, in this case, secure firewall, right, and how this fits within the organizational structure. And I will show this data center guardrails policy in a moment, right? But I just want to keep for you focus on this hierarchical approach, right, where we have the specific application policies at the very bottom, and then we have these guardrails or security mandates that will have priority, right, always, and they are always on top. So I click next and accept and enforce, right? So at this point in time, the policies are being orchestrated to secure firewall through FMC, right? So we're pushing those roles to FMC. But before navigating to FMC, I now want to go and talk about the data center, right? These guardrail policies that I was mentioning before. So I will open this data center guardrail policies, right? And before you saw the policy canvas view, right? Where the policies are in this nice, graph view of how they are defined, but you also have the option to see the policies in an access list control fashion, right? And for this purpose, we will use this one here. And what you can see here is that I'm defining at the data center level, right, this intelligent zone segmentation, right, or intelligent zone segmentation guardrails, where, for example, we have some mandate that we don't want contractors, right, and you can see how we are discovering those contractors, right? We don't want them to talk to our core services, right, on any protocol, right? And you can see here our core services, that is our environment, right? Or for example, if there is a malicious ransomware that just broke out, right, on the organization, how you can quickly look for those, for that process binary hash and identify workloads with that specific binary hash, so they will be blocked immediately, right? So you will enforce all of this policy right away, right, through all of your environment, right? In this case, I'm just specifying the data center and how we are defining it, right? Quarantine workloads, right? For example, if they have a specific label, in this case, quarantine, right? Or something very unique to Cisco, right? That in this case, we're using this risk score, right? Where we can evaluate the risk, right, of vulnerabilities and give you a more tailored definition of the risk that a vulnerability may have in your environment. And in this case, what we're looking at is vulnerabilities that have a risk score greater than 97 or are high, right? And then they are easily exploitable, and how those workloads will be automatically discovered and put right into this policy if they match any of those, any of that context, right, of that query. Of course, we have development cannot talk to production environment, right? And core services cannot talk to specific malware domain that we have defined, right? So this is our guardrails that we want to establish within our data center environment, right? Our data center um, organizational structure, right? So here I will just go through the wizard where I will just enforce that policy, right? You can see the multiple workloads this policy will apply to and how they fit, right? Again, within the organization hierarchy, right? They are always on top, and I accept and enforce. So right now I'm pushing these policies to FMC, right? To our secure firewall enforcement point. Now I will navigate to connectors. And here you can see all the different integrations that we have, right? For example, the cloud service providers, load balancers, right? CMDBs such as ServiceNow, ICE, among others. But I want to navigate to Cisco Secure Firewall, right? And here, this is how we integrate with FMC. We call this the FMC connector, right? And you can see that I already have one enabled with the DC FMC, right? This FMC that I was showing just a minute before. And you can see here how I'm doing this access control policy to scope mapping, right? To inventory mapping, where I define an access control policy that I will map to scope within my organizational structure, right? Or my hierarchical structure. In this case, a data center. I will use the default action on FMC established by FMC and how I am honoring, right, the existing policies on FMC, allowing for this dual management, right? And that is what is called this enforcement mode. If you have merge option, you can have this dual policy management where secure workload will honor existing rules, but you can also decide to override and only have secure workload owned rules on FMC, right? And how you want to position those, right? Either above or below the existing rules. Right. So now we'll navigate back to FMC, right, to the policy editor, and you can see here how the API user, right, that in this case secure workload is using to automate policies in FMC, right, to deploy those policies, to orchestrate those policies on FMC. So I will refresh the tab here. Let's just give it a moment. right? And here we can see right away we have these golden rules, right? That secure workload defines automatically as soon as you have the integration, right? But just below the mandatory section, right? Keep in mind that we're in the mandatory section. On the default section, we see the application and specific rules, right? And I will just make this a bit bigger, where we see the job host, right? The web front, the core app nodes, the Redis cache, right? That is talking to the DB nodes, as you can see here, right? So these are the finance app, right? Or the application specific policies that secure workload is orchestrating on the firewall, right? So you have this microsegmentation policy using a network enforcement point, right, for that specific application without needing to deploy an agent. And we see then how it honors, right, that existing rule that was the DHCP rule that was defined previously, right? As we speak, secure workload is orchestrating those security mandates, right, that we define afterwards, right, at the data center level, where it is defining those security mandates. And those security mandates, since they have priority, right, they will be defined at the mandatory section of FMC, right, at the top, because they must always be on first priority, right, for access control. And here then we can see, right, how the API is already kicking in, right, to orchestrate those policies. I will just refresh back again. Right, and we can see those policies being orchestrated on FMC. And let's just wait for it. And here you can see, right, we're in the mandatory section and we have those block statements, right, blocking that those are specific policies, right? The contractors cannot talk to the core services, right, or this ransomware, right? Workloads with that ransomware cannot talk to those specific workloads, right? For example, here we see the data center or some Kubernetes clusters, right? With the risky VDI workloads, right, cannot talk to the internet. So we push all of those policy guardrails, right, always on top, and in this case as well on top of existing FMC rules, right? So this way we allow for that dual policy management. All right, so now we'll navigate back, right, and I want also to show you very quick, right? I will navigate now to agents, and I talked before about the microsegmentation using agents, right? Where we have this microperimeter at the workload level. But before talking about the enforcement capabilities that we have, I just want to show you here a quick pic, and I will just select this AKS Ubuntu workload, right? Of this runtime visibility that we have for the workloads. So you have all of this e-state of your workload, right? Where we can quickly check the long-lived processes that are running on that workload, right? And all the different information, right? For example, the last seen, right? The CPU usage of those processes. Oh, I think this was long, right? The username, the process ID, right, the memory usage, as well as the process binary hash, right, if it is malicious or banning process, right. We also have the process snapshot where we can keep track, right, of all the processes that are being executed at runtime, right, even if they have some vulnerability. For example, in this case, you can see how this process, right, it has a vulnerability, right. Python 3 has this 3 vulnerabilities detected, right? And you can see all of those different processes, right? In this is process tree snapshot, right? Who is the child process, right? Who is the parent process, right? And how it looks over time, right? For your workloads. I have the packages information, right? And if they are vulnerable, as well as the vulnerabilities associated with that specific package, right? So now I will navigate to my scope and inventory. And what I wanted to show you here is some additional enforcement capabilities that you have when you're using the agent. So I will open the terminal and services policy workspace, right? And I will switch to the policy canvas view. And with the agent, right, a part of having this microperimeter, for example, if I see this jump host, right, and I will select this policy over here, right, the jump host accesses some packages over the internet, right, that we can filter or create policies, right, based on domain name services, right. I want to focus your attention on this additional controls that we can do. So you can see here that we have a policy for that particular jump host accessing those package repos on port 443, right? But apart of that, this policy has a process level control, right? So if I click on it, right, I can go not only from the networking perspective, but also to the process level perspective, just to specify that this jump hosts are capable of accessing those packages repos over the internet, right, using port 443, but at the same time, only using Chrome, right, as the web browser, right? They cannot use, for example, Microsoft Edge or Firefox to access those specific repos, right? So I will just cancel here and I will navigate back to my presentation because there is also one additional capability that I want to show you, right? And that is about quarantining these workloads, right, based on CV and, or the process. And before we saw, right, how you can use, for example, the package information or the process binary hash or the Cisco risk vulnerability information, right? But this type of policy control might be disruptive for some organizations, right? You may have some sort of web server or a specific application that cannot be down, right? And this, in this cases where the a virtual patch, right, might be required, right, where we need to allow access of that particular application, but we just need to block the exploit or whatever vulnerability can be exploited, right? Just that particular action. And in this case, leveraging secure firewall integration, right, we can push, right, from the agents that package information. So on FMC, you can run firepower recommendations and get the specific IPS signatures for your environment, right? So you can have enabled, right, that particular signature if someone tries to exploit that workload or try to get advantage of that vulnerability, you can catch it with this Snort IPS signature. All right, and if I navigate back to FMC, right, and perhaps before going to FMC, let's check the FMC connector and secure workload, right? So we can see how this virtual patch looked like, right? And before, you saw the segmentation use case, right, or the segmentation capability. But now we will see the virtual patch capability. And here we have a rule defined, right, that we have this vulnerable automation server, right, that has this specific address, and I don't want any vulnerability that has a score above 4 to be exploited, right? And if I click here on the severity list for that specific workload, we can see all the different vulnerabilities that we have detected matching that specific query, right? So these vulnerabilities that you see here are the vulnerabilities that I will export to FMC, right? So if I navigate back to FMC, and in this case, I will navigate to analysis and third-party vulnerabilities. You can see here how secure workload, right, is pushing those vulnerabilities to FMC, right? So in this case, 71, right? And you can have all the relevant information, right? For example, if I click on host, right, that specific IP address, right, and the different vulnerabilities that secure workload is pushing, right, based on the agent information, right? So you see all of those different ones that are associated with that specific host. And if I navigate to table view of third-party vulnerabilities, you will see which of those CVEs have signature associated to it, right? And here we can see how, um, for example, if I navigate here, the different vulnerabilities, right, that we have detected for that host. And let's see if we have any signature. So for this one, probably don't have any signature, right? But if there is a signature associated to it, it will be shown here, right? So navigating back to our presentation, this was the last bit of it, in a matter of fact. And having said this, we have come to the end of our webinar, but I hope this has been informative for you, and you have learned something about Cisco Secure Workload and Cisco Secure Firewall and how the two of them, right, combined and working in tandem can add value to your organization, right, to contain and possibly mitigate, right, if available, right, if possible, the ransomware threat, right? So you have a part of more of the prevention of ransomware to consistently enforce all of these policies, right, in this distributed fashion across different environments, right, from one single point of view, right? And having said this, I want to thank you for viewing this, and thank you very much.